right, class, welcome back to our unit on volume. And today, we're going to learn about the surface area and volume of spheres. We haven't talked about spheres yet. So if you haven't yet watched the videos on prisms and cylinders and composite figures or pyramids and cones, it'd be a good time to stop this and check that out because it's pretty good video stuff right there. And we're going to refresh a little bit of memory before we jump into formulas and stuff. Talking about units of measure. So we have to remember units of measure when we're talking about volume, especially in this one. So if we're working in one dimension, which is only a distance or a length or a perimeter or circumference, we are talking about just units. Okay, so centimeters or meters or yards or feet. If we talk about area, we're talking about two dimensions, and so that's squared centimeters or squared meters, square yards, square feet, square units. If we're talking about volume, we're talking about three dimensions, and we need cubic units. Okay, cubic centimeters, cubic meters, cubic yards, cubic feet, etc. This is important to refresh for this because what we're talking about in this video is both surface area and volume. Okay, so sometimes we'll be working in two dimensions when we're talking about surface area. Sometimes we'll be working on three dimensions when we're talking about volume. So let's jump in because this is a formula-heavy lesson. Let's go figure out what's going on here, shall we? Yay! All right, so we got some notes on spheres. Now the first note on spheres regards surface area. So we're talking about the surface area. It's the way around, like the area around a sphere. That's a messed up shape. You know, how are we going to figure that out? Well, fortunately, there's a neat little formula to help us, and that formula is 4 times pi times the radius squared. It's basically 4 times the area of the diameter of the sphere, right, or the circle that is around the diameter of the sphere. Cut that sphere in half. So it's 4 times the area of that. 4 pi r squared. Piece of cake. The only thing we have to remember that gets tricky is that this is area, and so we're dealing with squared units. Okay, surface area is indeed area. We're dealing with squared units. And there's a formula, and it's not that difficult. 4 pi r squared, 4 times the area of the center of the circle, center of the sphere. Okay, the next formula deals with volume of the sphere. Okay, so we're filling up the sphere now, right? Three-dimensional stuff. It's inside, not just the surrounding outside, but the inside itself. And the formula of the volume of the sphere looks kind of scary because it has a naughty fraction. Oh no, 4/3. Ah! Okay, so no big deal. 4/3 pi r cubed. Pi times the radius cubed. And there's going to be some neat calculator tricks we're going to go over in this video, so pay attention to when we start using the calculator. It's going to make your life a lot easier. The thing to remember that this is volume, therefore we're dealing with cubic units. Okay, so let's jump into examples, right? Let's get our hands dirty and do some examples. The first example deals with surface area of a sphere. So this is a simple question. What's the surface area of the sphere in terms of pi? Okay, so we want an exact value, no rounding. All right, so no rounding here. We're going to leave pi by itself, but it's a surface area question, and the formula we just learned, surface area is 4 times pi r squared. The only thing we have to figure out is what is r? Okay, so what is the radius? Now, if we cut this sphere in half, we see we have a diameter of 10 meters. Therefore, the radius is 5. So it's a real simple question, right? The surface area is 4 times pi times the radius squared. Okay, times pi squared. So the only thing we have to remember is when it says in terms of pi, we're going to leave pi alone. Okay, leave pi alone and just figure out 4 times 5 squared. Now, quick trick, if you don't know, 5 squared is 25, right? 25 times 4 is like 4 quarters equaling $1. That's a hundy. Okay, so we have 100 there, and then our pi. Right, so that's how that works without a calculator, so you can figure that out. All we need to do now is worry about our units. We're talking about meters, but this is area, so we're going to be talking about squared meters, and that is our result in terms of pi by itself. Now let's talk about another question. Now this is words, no pictures, okay? We can do this. What's the surface area of a sphere? Okay, that's doable. We know the formula we're working with. Has a diameter of 14 inches. We got that down. And now what we're going to do is give our answer both in terms of pi, an exact value, and rounded. Okay, so we're going to do a couple of things with the calculator here. I'll show you some tricks. So anyway, we're talking about surface area of a sphere. We already know we're dealing with 4 times pi times the radius squared. And so we know we'll be dealing with that. And we know what our radius is. If we have a diameter of 14 inches, we know our radius is 7 inches. Okay, so it's not that big of a deal. We just use the formula, right? So 4 times pi times the radius squared. No big deal. So when it comes in terms of pi, so our exact value is no big deal. Our exact value is going to end up being 49 times 4. Okay, so, or we can do this, 7 squared, okay, times 4. If we use our calculator tricks, we can find out some neat stuff. It's 196 pi. Okay, remember, exact value will leave pi by itself, but we're finding 196 is 4 times 49, so 196 pi. All we need to do now is deal with units. So we're talking about inches, we're talking about area, that's square inches. Okay, so our exact value is 196 pi square inches. Okay, but how do we round it to the nearest square inch? What do? Very simple. We multiply 196 times pi. No big deal. So watch this. Times pi equals. And we're going to round it to the nearest square inch. Okay, so look, we have 615.75, whatever. That 7 is going to round it up to 616. Okay, so our exact value we have, and now our rounded value we have as well. It's 616 square inches. All right, so we have to make sure we're reading directions carefully so we know how we want our answers. All right, let's do another example. This one's a bit more fun. And fun for me is not so fun for you. So let's pay attention. We'll have a good time. All right, so now we're talking about Earth's equator, about 24,900 miles long. What's the approximate surface area of the Earth round to the nearest 1,000 square miles? Okay, so what's the question asking for? We're asking for the surface area of the Earth. And we know that the Earth is a sphere. So we know we'll be dealing with surface area equaling 4 pi r squared. The only question is, what's the radius of the Earth? That's where this little tidbit comes in handy. Earth's equator is about 24,900 miles long. So we have to figure out, what does that mean? Well, if we picture the Earth, we need to know what the equator is. If you don't know, the equator is that center belt, right, that goes around the middle of the Earth. So that's the equator, okay? And if the equator that goes around the middle of the Earth is 24,900 miles long, what does that even mean? Okay, so now we got to think, what does that mean? The equator represents circumference of the Earth. We have to know that. So the equator represents circumference of the Earth. And this becomes tricky. So if we know the circumference of the Earth, okay, now we can start working our way back. So we have our circumference of the Earth. The circumference of the Earth is the equator. It's 24,902 miles. Now the trick is okay, I'm following you so far, Mr. Katz, but I still don't see where we're getting our radius from when it comes to the question about surface area. Where's that radius going to come from if we know our circumference? So I don't want to spoil it yet. Hopefully you're thinking, ooh, Mr. Katz, like you're yelling at your computer screen right now. Ooh, Mr. Katz, I know. Because I know the formula for circumference is 2 times pi times the radius. That's my formula for circumference. If I know my formula for circumference is 2 times pi times the radius, and I know the circumference is 24,902, I can figure some stuff out. We're about ready to learn a calculator trick. So once I know this, now I have access, because the radius for the surface area is the same radius. It's the same radius for circumference. Okay, so it's going to be the same radius. All we have to do now is some basic pre-algebra, and we're going to solve for the radius here. So how do we do that? We divide both sides by 2 pi, and I'll show you a calculator trick. Okay, so the radius is going to be equal to what? We're going to crunch this big number, and we're going to use a tool to help us. Okay, so here's how this is going to work. I think you're going to like it. So if I were just to divide 24,902 by 2 pi, how would that work? So 24,902, if I say divided by 2 times pi, look what happens. The calculator has already crunched 24,902 divided by 2. That's not what we need. Okay, what we needed to have it do is divide by 2 times pi. So how did this stupid calculator do what we want it to do? Come on, stupid calculator. Do what I'm asking you to do. That's where these little buttons come in. You ever seen these? Open parenthesis, close parenthesis. They're grouping symbols. So what we can do is group the denominator. If we group the denominator, we're going to have our accurate value. So let's try that. 24,902 divided by grouping 2 times pi. Close the group. And notice how we have 2 times pi. It's 6.28. And when I hit equal, I will have our accurate value. This is not 24,000 divided by 2, then times pi. This is 24,902 divided by 2 times pi. We viewed the grouping symbol. So once we've done that, we have found our radius. Our radius is indeed 3,963, and we'll use some more digits. Okay, so we'll say 3,963 point, we'll say 276. Okay, we'll bring out 3 digits, why not? Okay, so we have now found the radius based off of the circumference. And remember what we have said. The radius for the circumference is the exact same radius for the surface area. We have now unlocked what we need to figure out. So now we can answer the question. So the surface area is indeed, surface area of the Earth is 4 times pi times the radius squared. We just found the radius. 3,963.276 squared. Okay, so all we're going to have to do now is round that. I'll talk about that in a second. So let's crunch some numbers. This is going to be a big, big number, but we're going to learn some stuff, okay? Okay. So how does this work in the calculator? So now with this, we're gonna crunch in our handy tool. I start with the squaring first. So 3,963.276. I'm going to square that. So I'm going to use my squared button. I'm going to multiply that by 4. I'm going to multiply that by pi. I'm going to get some really, really big number. So this big number, I'm going to write down all the digits and we'll figure out what's going on. Okay, so we got a 1, a 9, a 7, a 3, an 8, a 6, a 9, a 7, an 8, and a point, and a 3. So this is the big result, right? But we have to read the directions, round it to the nearest 1,000 square miles. So we have to remember how our place value works. Here's our decimal point. There's our 3 digits to get to our thousands, and then 3 more digits to get to our 100,000s. So the nearest 1,000 is this digit right here, okay? So notice it's the digit 6. That means that digit 9 is going to round that digit 6 up, okay? So that's our goal in mind. So what we're actually dealing with is 19738. This is now 7000. That is rounded to the nearest 1,000. Okay, so hopefully you remember some place value stuff from real elementary math. All we're going to do now is figure out what this number is. Okay, so 3 digits, comma for 1,000s, 3 more digits, comma for 100,000s. And now we see we're dealing with 197 million, right? So that's how that works. 197 million. So on and so forth. But this is rounded to the nearest 1,000 miles. 1,000 square miles, which is my last point. We need to use proper units of measure. So that is our surface area of the Earth, given the Earth's circumference. See, I told you it was a neat question, and I told you, like, oh, no, I don't like neat. Okay, so let's move on to the next thing. The next thing is now going into volume. Okay, so we have to remember the notes at the beginning of the video, which I'll refresh your memory. What is the volume of this sphere in terms of pi? Okay, so now we're going back to the concept of volume, And we have a neat little formula. The volume of a sphere, 4/3 pi r cubed. 4/3 pi r cubed. I'm going to teach you a neat trick. Okay, so all we need to know in this particular example is, what is our radius? Our radius is given right here, right? The radius of the center of the sphere, 6 meters. So this is a real simple question. Volume is 4/3 pi times the radius cubed, 6 cubed. All right, so a couple things. First thing we're going to do is leave pi alone because this question is in terms of pi. The second thing we have to do is figure out how we're going to work with 6 to the 3rd power. So another calculator trick. How do we figure out 6 to the 3rd power? Well, we do know that that means 6 times 6 times 6, right? So we know whatever we're going to use for the calculator is 216. I can do this quicker. And how? This button right here, y to the x. So how does y to the x work? We're going to read 6 to the 3rd power. When we read 6 to the 3rd power, we're going to use that button. 6, okay, to the, call that the to the button, 3rd power, equals. Isn't that neat? So now we have a new button at our disposal. Now another new button to help you with is this 4/3. How is that going to work? So can we multiply 6 to the 3rd power times 4/3? Yes, we can. And we also say times 4 equals divided by 3 equals. We know that. Okay, so we know we're going to get 288 somehow. But how can we work with 4/3? There's another button that can help us. It's this button right here. That's going to give us fractions as we type this in. This calculator cheats. So I'm destroying a bit of my soul when I show you this, but watch. 4/3. Isn't that neat? Times 6 to the 3rd power equals 288. Isn't that neat? My soul just ripped in half by showing you a cheat, but whatever. So either way, we get 288 pi meters what? Okay, we're back to volume. So if we're back to volume, we're doing cubic units, meters to the 3rd power. So I hope you enjoyed that calculator trick. I got more coming. Stay tuned. We're going to need some practice on that. Okay, next question. Here's the question. A sphere has a diameter of 60 inches. What's the volume to the nearest cubic inch? All right. So volume and nearest. Now we're going to round. Okay, so now we're going to round. So we know volume. Again, volume is 4/3 pi r cubed. All we need to know is what's the radius. If the diameter is 60, that means the radius is 30. Okay, so we have seen worse things. So all we have to do is plug in what we know, right? So 4/3 pi times the radius cubed. And the rest is calculator work. So how does that work? I'll show you. This is nuts. So I'm going to do some cheating. You guys ready? Follow what's going on. 4 fraction button thirds, okay, times 30 to the 3rd power is 36,000. And totally, by the way, it's legit. So we know it's 36,000 pi. Okay, so even if this question were asking for exact value, this is what we would use. It's 36,000 pi, but it's not asking for exact value. This question is rounding to the nearest cubic inch. So we have to remember to read directions. So 36,000 times pi equals, all right? So we have this crazy number, and we're going to round that. 113,097.33. Rounded to the nearest cubic inch, that's rounded to the nearest whole number, that gives us our final result, 113,097. And we have to just know where our commas are so we can read this like a grown-up. That's 113,000. Okay, so 113,097, what? Cubic inches, inches to the 3rd power. This is volume. Okay, so this is volume. So if we wanted exact value, we could go here. If we need to round it, we're going here. We're going to multiply by pi. All right. Now, I hope that was helpful because here comes a doozy to wrap this thing up. This question is a doozy. Buckle your seatbelts. I think you're going to have fun. If I can turn the page anyway. All right. So look at this. One tiny sentence, but good Lord, is it a good one. The volume of a sphere is 5,000 meters cubed. what's the surface area to the nearest square meter? So this is actually a surface area question. As we know, surface area is 4 pi r squared. But the question is, what is the radius? We need to know the radius. We don't have the radius. We have the volume. So we got to do some thinking. We don't have the radius, but we do have the volume. It is time to do some thinking. The volume of the sphere is 5,000 cubic meters. How are we going to find the radius? So do your thinking. I want to ruin it for you. You're thinking, and you're like, ooh, Mr. Katz, I know, because the volume of a sphere is 4/3 pi r cubed. Since I know the volume of a sphere, I know that 4/3 pi r cubed is 5,000. And the r here for the volume, the radius for the volume is going to be the same as the radius for the surface area. So Mr. Katz, I know that. I'm a good thinker. And I'll acknowledge you and I'll say, good job, and here's a cookie or virtual point or whatever. So now the question becomes, how do we solve for the radius here? Oh, we got some good algebra here. There's a bunch of things that we can do to solve for r. First thing we can do, if we choose, we can multiply both sides of the equation by 3 so we can get rid of our denominator, right? Let me go nice and slow so I can take it easy on you. And then we can divide both sides by 4 pi. Okay, so follow me on this. This is going to be fun, and we'll have a cheat in the calculator to help us. So we know the radius cubed will be some big number. Now remember how we're going to do this. We need to use the grouping symbol for 4 times pi, so let's do that. So we have 15,000 divided by grouping 4 times pi, close the group, equals. Okay, so we have this big number. Okay, so the radius cubed is 1193.662, let's say. But if that's the radius cubed, how are we going to solve for r? How are we going to solve for the radius if we have the radius cubed? Well, if we undo to the 2nd power with square root, we will undo to the 3rd power with cube root. That's right. So we got some algebra 1 kicking in. If we undo 2nd power with square root, we undo 3rd power with cube root. But how does that work? Where are we going to find the cube root button? Well, remember our to the button? Well, over the to the button is the root button. Okay, so we can do a cube root button. Okay, so how does this work? This is what in the calculator now, this is what our cubed is, right? So the radius cubed is this number. To take the cube root, we're going to hit the 2nd to the, but that's the cube root. So we're going to take the cube root. As soon as we hit equals, we'll have the radius. Boom. So the cube root of that, our radius, is revealed to be 10.608. That is our radius. Okay? So we had to figure all of that backwards from volume using some neat calculator tricks. Okay, so some neat stuff. We got to know some algebra and some neat calculator tricks, and now we can wrap up our question, because the radius for surface area in the original question is the same as the radius given from the volume. So we have to remember that. So the surface area is 4 times pi times the radius, which is 10.608 squared, and boom, bit, we're home. So some quick calculator work, and I'm wrapping this video lesson up. Okay, so 10.60, let me know how to use calculator, 10.608 squared times 4 times pi, boom. There is our surface area. So we have 1414.089, and the directions read to the nearest square meter, which is only here, so 1414. Squared meters, that's what we got, 1414 squared meters. So we do have some neat problem-solving skills to use, some neat algebra, but some neat calculator tricks as well. And that's it for the unit on volume. I hope you guys enjoyed it. and learn some stuff. Peace out.